Welcome to David Alexander Maths Tuition. This is Chapter 5C on arc length. Okay, so Chapter 5C, definitely not the hardest chapter in the Year 13 course. How do we calculate the arc length in radians? Well, first of all, how do we do it in degrees? If I'm trying to work out the length of this arc, and I know that this angle is, well, whatever, let's just call it theta, then that is going to be theta out of 360 multiplied by the total circumference, which would be 2 pi r. There we go. So that's the kind of formula. Maybe it's not one that you kind of learn as a formula. Maybe it's quite an intuitive thing for you to do. So in radians, again, it's very, very simple. So again, like if this angle here is theta and we want to work out this arc length, it's a similar formula, but instead of it being 360 degrees, how many degrees are there in the full circle? Well, that is 2 pi. So it's theta over 2 pi multiplied by 2 pi r. Now, the 2 pi on the bottom and the 2 pi on the top can cancel. So therefore, the arc length is just, if we want to call this L for the length of the radius, then L is theta multiplied by r. So the arc length is theta r. Easy. Okay, so we know that from the previous slide that the arc length is theta multiplied by r, so therefore L is just going to be 0.65 multiplied by 4 in this first example, and 0.65 multiplied by 4 is 2.6. Okay, here we want to find r, so L over theta is r, just rearranging that equation, so that's going to be 12 divided by 0.65, so therefore r is 240 over 13. And theta, when L is 15 and R is 7, well, that is just going to be L over R equals theta. So therefore, we just need to do, 15 over 7. We'll just call that 15 over 7. There we go. Or the decimal equivalent, which is 2.14. So here theta would be 2.14 radians. There we go. Okay, so there's a question similar to this in the book. So here's my circle. The minor arc subtends an angle 2x. So therefore this is 2x. And the major arc subtends an angle 3x. Okay, so this is 3x. So what we know is that 2x plus 3x, so 5x equals, you're probably going to be thinking 360 degrees, but that is going to be 2 pi radians. So therefore x is 2 pi over 5 radians. So therefore we want to work out this minor arc AB. So we know that the angle is 2x, so 2x is going to be 4 pi over 5 radians. And we know that the radius is 15 centimeters, so therefore the arc length L is theta multiplied by r, and theta is 4 pi over 5, and we're going to be multiplying that by 15. So 4 pi divided by 5 multiplied by 15 is 12 pi. There we go. So in terms of pi, the length of the minor arc is 12 pi. Okay, so we want to work out the perimeter of the yellow shaded region. So that is going to be one arc length plus 5 plus a bigger arc length plus another 5. So we've got a 5 plus a 5, so that's a 10 plus. So this arc length, remember that the arc length is theta times by r, and we know that theta is 1.2. So 6 times by 1.2 is 7.2, so this arc length is 7.2, and this bigger arc length is 6 plus 5, which is 11. 11 times 1.2, which is 13.2. Okay, so therefore the total arc length is 10, sorry, not the total arc length, the total perimeter is 10 plus 7.2 plus 13.2, and so 17.2 plus 13.2 is 30.4. There we go. So that is the perimeter of the yellow shaded region. Okay, moving on to the next part. So here we're working it backwards and we don't know what theta is. Let me just delete these values here. So we're trying to work out what theta is, and we know that the perimeter is 32. So what I'm going to do is I'm going to take off the 5 and the 5. So that will take me down to 22. So 22 centimeters equals, these two sides, these two arcs A and B together. So A plus B is 22. Now we don't know what theta is, but A is going to be 6 times theta, so that is going to be 6 theta, and B is going to be 11 times theta, so 11 theta. So what we can say is that 11 theta plus 6 theta, which is 17 theta, equals 22. Therefore theta is 22 over 17, and 22 divided by 17 is 1.29. So theta is 1.29 radians, and that's just correct. 2 decimal places there.